Hey everybody, this is Quinn Devery, and today I wanted to spend a couple minutes talk about what is the deal with vectors and generative AI. If you've been in the space, there obviously comes up a lot, and so it's something I've learned recently and wanted to share with y'all. So, real quick, what are the three things we're going to cover? First, we're just going to give a vector example. It's something that you intuitively understand: red, green, blue, RGB on electronic devices. Then we're going to talk a little bit about vector search versus text search as an example, and then your use of vectors or use of vectors in generative AI. So I want to give a shout out to JP Wang. He had a great article. I got this from a peer, so no credit to myself, but it's really kind of the foundation of the content that I'm sharing. I'll include a link as well for you to go check out. A really great article. Appreciate JP for breaking this down. So, vectors essentially are, a multidimensional array of numbers. And so, we want to take something super simple and it's got a great 3D representation. If we go back to high school or college, like, X and Y, X, Y, now add Z. And so if we've ever been in PowerPoint or looking at RGB, you can see here red, 255, comma 0, comma 0, or green is 0, 255, 0, and blue 0, 0, 255. And it's an additive scheme. And as you can see in the image here, a combination of those three colors that come up with this, nice gradient of colors that we use on our electronic devices. So it just so happens that gray is 128, 128, 128 in red, green, blue. And so if I were to ask you, of these two vectors, 127, 127, 127 versus 55, 0, 55, which one of those two vectors is closest to gray? What would you say? Not a trick question, super intuitive, right? The differential between the 128, 128, 128, and 127, right? That's 1 versus it's much greater for 55 and even greater for 0. So, fundamentally, that's, how you look at vectors and proximity and which ones are close or not. So we take this a step further and we say, okay, so we've got, text search. And so we did a text search. It's going to look at all the different colors in this RGB gradient. And then it's going to come up with 14 different answers: blue, gray, dark gray, gray asparagus, which always makes me laugh. Versus what we see on the right here is actually a vector search, and there's 96 colors in the RGB arena that pop up when you do a vector search. And gray and battleship gray and camouflage green, bizarre, Zandu. So, I think this is truly, to me, what was an eye-opening experience on the power of vectors, because what you're doing is you're taking that gray data point, in this case it happens to be, three-dimensional, and then you're looking around that. And so I'll just go to this visual image, and you're calculating the proximity to gray, 128, 128, 128, and then the other ones, regardless of their actual name, right? Because that's a human added element. And so on the left here, we did the text match, and you can see the distribution here, clustering. And then on the right, you can see, why there are so many other colors, just because the distance. And you can obviously scale this down. And so you get a tighter cluster of what's closest to gray. So why does this matter? Well, if you're using any large language model today, they're already converting vectors, your text to vectors, because fundamentally computers don't understand text. So they break it down into a vector format, which is a series of numbers. So you take your prompt in, they convert it, and so that something a computer can understand. Well, what if we took your business, or if your business took the treasure troves of PDFs and documents, internal documentation, or perhaps community facing, actually batch that into a vector or vectors, and then store that in a vector database? That would be a natural extension of your GenAI journey with large language models, because now you can essentially match these prompts to your database to find the similarities, right? And so this is going to come up with we're seeing a lot of cool productivity use cases. One example that resonates with me is customer service. Imagine going to a website, customer service agent, you put in a question, maybe it's technical, very nuanced. And so immediately that question would go into the generative AI application, and it would then reference your knowledge base that you've put in the vector database, and then come back with 3 possible answers and links to those respective websites or documents. Now the customer agent doesn't have to spend time sorting through all of that data and can provide and make a decision real time of what information they should share based on the context cues and their experience in the job. And so another benefit of this is you're going to get reduced hallucinations of the LLM outputs, because you're really kind of forcing it to use a data source to match versus coming up and trying to predict the next best word in the series. So some key takeaways, vectors are way less complex than you need to think about. So, essentially you're trying to represent a color as a vector, and we do that with red, green, blue all the time, and that's just a 3-dimensional vector. And in GenAI, vectors are typically significantly more multidimensional. LLMs already use vectors to take human text and convert that into something that a machine type language that they can understand. And so implementing something called RAG, or retrieval augmented generation, is a natural kind of next step that could really help with your GenAI use cases. And because it's going to improve the quality and accuracy of that generative AI LLM application, and typically that's done via RAG. So in this use case. So what's up next? Working on a video for what does a RAG implementation look like specifically on AWS, and are some of the different options on there. And then check out JP Wang's Hugging Face space, where that article is popped. Here's the link. I also published it below. So hey, thanks for spending time with me today, and see you next time.